Hello everyone, this is Ghasemi from the Heimer Lab at the University of Illinois at Chicago. In this session, I'm going to talk about applications of presenting, hand tracking, and streaming techniques to AR-based research for learning and training. Augmented reality has great potential for making learning progressively more dynamic, meaningful, and interactive. Specifically, during this time that COVID is negatively affecting the quality of education and learning while causing frustrations by making everyone do their works remotely, using AR can make interactions much more convenient and enjoyable. AR has been used for training and learning purposes in many areas, including medical operations, aerospace, manufacturing, military, and education. In this demonstration session, we will introduce three techniques on how AR technologies can be used for human factors research, especially to facilitate human interaction in learning and training. Our first demonstration addresses how to present real images and videos to users through wearable heads-up displays. For this demonstration, we used 3D CAD modeling in Blender for creating the app. The subject used the Magic Leap headset for interacting with the app. This technique can be used for providing maintenance and inspection instructions for training industrial workers or providing educational tutorials to students, which makes the process of learning more engaging and fun. It can also be used in healthcare. For example, vital information can be augmented for the medical team while they are performing surgery. The second demonstration explores the potential use of hand tracking for intelligent AR interactions. This technique does not require the use of any external electromagnetic controls and allows users to manipulate AR objects using their own hands. For this demonstration, we created the app using Unity and MRTK and deployed it to HoloLens 2. The subject interacted with the app using the hand tracking feature of the HoloLens 2. This feature can be used for creating safety measures. For example, we can define physical boundaries where the users must not reach for their safety and produce a change in color of the areas when they are touched by the user's hand. It can also be used for training, where workers can virtually practice several patterns of organizing objects, or even for home design, where users can try multiple design layouts by virtually placing furniture in different locations. The last demonstration introduces a streaming technology through which the users can share their AR scenes with others in real time. The previous demonstrations utilized single user interaction mode, but this technique can be used for synchronous remote collaboration where several people can work together on a single app. Another application is remote training, where employees or workers are connected with remote experts. The experts monitor what they see and provide them with real-time instructions. It can also be used for collaborative learning, where students are remotely connected to an instructor and receive real-time education. There has been an increasing amount of research suggesting the advantages of AR over traditional methods of learning and training, and yet there are many other potential areas worth exploring. Here at Heimer Lab, we are currently working on several projects in this area using the aforementioned techniques, including a presenting approach where we used AR to facilitate the data entry task for the office workers. We are also focusing on presenting and hand tracking approaches to train industrial workers for a specific warehousing task. There are some challenges mainly specific to the accuracy of AR devices. Recent research works utilize deep learning for ensuring higher accuracy to better identify objects and augment information. AR devices often have a limited field of view, which makes it difficult for the users to perform their tasks. There are also some concerns about the acceptability of AR devices among users. For example, AR headsets are bulky and heavy, and they may cause physical discomforts and motion sickness for the users. Many people haven't had the experience of working with AR devices, which may cause them higher mental load, frustration, and consequently, lower performance. This can be alleviated by training them before doing the task, but anyway, it's a limitation. AR devices mainly work in indoor environments where the level of lighting can be controlled. However, it is not the case for outdoor environments. When it's too bright or too dark, these devices are not able to accurately identify the environment. Thank you for watching. I would be happy to answer any questions you may have.